Welcome students, this video is on solving equation and it's for Monday, September 15th. Believe it or not, you have been solving equations since you were back in elementary school. They used to look a little bit different. They looked like this back then. 15 plus blank equals 20. And so you would guess and check and try to figure out answers that would go into there. But the smarter and smarter you got, you realized that all you had to do was do 20 minus 15. And so you didn't have to guess and check. You could instantly figure out what goes in there. Well, we're going to put some formal steps to these, and that way we can do ones that are more complicated than just 15 plus a blank, that have multiplication, division, subtraction, addition, fractions, all kinds of stuff in them. Alright, so you already know how to do one-step equations. You should have learned those at the end of 8th grade last year. Solving equations is all about doing inverses. Okay? And so I want you to write this on here. This is a vocabulary word, inverse operations. Okay? Inverse operations is just doing the opposite operation, like what it says here. If you see addition, you do subtraction. If you see multiplication, you do division. Okay? Whatever we do, because it's an equal sign, to keep things equal, you have to do the same thing on either side of the equation. So if I have an equal and I add 8 over to here, I have to add 8 to this side to keep it equal. If I divide by 4 over here, I have to divide by 4 over here. Whatever I do to one side, I have to do the other side, because that's the only way we keep it equal. You can think of it as kind of like a scale or a balance that you would see in science. Whatever we put on this side, we have to put on this side to keep it balanced. If we put a triangle on this side, we'd have to put a triangle on this side to keep it balanced. Alright, a solution is something that makes an equation true. We're just going to decide if the following solutions are the right solutions or not, if they're true statements. So what we do to check an answer, we've been told that x equals 4. We're going to take that, and anywhere we see that in the equation, we're going to plug it in. We use parentheses to plug it in. So instead of 3x, we're going to say 3 parentheses 4 equals 12. And put a question mark above it, because that's what we're trying to see. Does that equal 12? 3 times 4 is 12. 12 equals 12, so this is a yes. Okay. Here we're going to put 7 in parentheses over here. So 7 minus 3 equals 10, and question mark. 7 minus 3, 7 take away 3 is 4. 4 does not equal 10, so this is a no. Alright, so our goal of every equation is to get the variable, the letter, on one side by itself. So we'll end up with the letter on one side and then everything else on the other side. Here in the beginning it'll just be a single number, but later in the year we'll end up getting the variable on the side and there'll be a bunch of other stuff on the right hand side. But that's our goal when solving every equation, to get the letter we're solving for on the left by itself. We've got a bunch of steps here to help us through that process. You see a lot of if needed, and that's basically because every problem is unique. Not every problem needs the same steps. This is kind of a checklist of things that we need to check to see, do we need to do these? Okay. Before we start all of our equations, we like to draw a line down here, and this just separates the left from the right. Whatever we do on the left, we got to do on the right. Step 1 says simplify both sides. 4y minus 9 cannot be simplified because those are unlike terms. There's nothing on the other side except for 15, so no simplification can occur. Step 2 says move the variable to the left-hand side. It's already on the left-hand side, so that step is done as well. Step 3 says add or subtract away the term with no variable. So negative 9 right here, or minus 9, is the term with no variable. So we're going to add or subtract using inverse operations to get it to the other side. Anytime we see minus, we do plus. Whatever we do to the left, we do to the right. Negative 9 cancels out. We bring down our 4y. 15 plus 9 is 24. Step 4. Divide or multiply by the coefficient of your variable. When it's beside it, you divide it. My 4 is beside the y, so I'm going to divide both sides by 4. And so I get that y equals 24 times 4 is 6. And that's my answer, y equals 6. So let me now check my solution. So I check it by using parentheses 4. Instead of y, I put in 6. Minus 9 equals 15, and again, that's a question mark. 4 times 6 is 24. 24 minus 9 equals 15. 24 minus 9 is 15. 15 equals 15. So I am correct. Okay. Number 5, we draw our line down. We look at the left side, it's simplified. Look at the right side, it's simplified. Step 2, we look to make sure our variable is on the left. It is. Step 3 is to add or subtract away the term with no variable. So I'm going to subtract away this plus 7 by doing minus 7. Whatever I do to the left, I have to do to the right. 7 and minus 7 cancel. I bring down my negative 6x. Negative 5 and negative 7 is negative 12. Divide or multiply by the coefficient of your variable. When it's beside it, we divide it, so I divide both sides by negative 6, and I get that x is equal to positive 2. Let's plug it back in to make sure. Negative 6, parentheses 2, plus 7, does that equal negative 5? Negative 6 times 2 is negative 12, plus 7 equals negative 5. Negative 12 plus 7 is negative 5, and that does equal negative 5, so we are correct. When we get to this second section down here, we're only going to do number 9, 10, and 12. But you are to do all of them. Oops. You are to do all of them. Okay? So you're going to do number 7, 8, and 11 on your own. Okay? Alright, so on number 9, we draw our line down. And we look at the left and we look at the right, and they're both simplified. So then we go to the second step, and that's to make sure our variable is on the left-hand side. Ours is not on the left-hand side. So we have 2 ways we can get it there. We could use inverse operations to move it over there, but then that would create a lot of extra work. I think our best bet to do is, if you don't like it on this side, just move the 69 over and get rid of it and work the problem from this side. And that way we just get rid of this and we kind of start back over with it on that side. I think that's your best bet. So again, both sides are still simplified. We start by getting rid of the term with no variable, so the minus 6 gets a plus 6 and a plus 6. So I'm going to move this over just a tad bit and make my line go this way a little bit. So 6 and negative 6 cancel. I get 7v equals negative 69 plus 6 is negative 63. And then when it's beside it, I divide it. So divide both sides by 7, and I get v equals negative 9. Okay. We'll start to learn in class on Monday how to check these in your calculator, but all we would do to check this in our calculator is do 7, parentheses negative 9, minus 6, and then we're just checking, we're going to hit enter and see, do we get negative 69? And we will if we got it right. If we missed it, then you'll see that you missed it. Okay, number 10, draw our line down. Just like when we were simplifying things, anytime I see a lonely number, I like to put a 1 in front of it. Okay, I look at the left, it's simplified. I look at the right, it's simplified. My variable is on the left like I like. Now I'm going to move the term with no variable. So these are kind of out of order from what we're used to seeing, so I'm not moving the negative 1y because I moved the term that has no variable. This is a positive 3, so I'm going to minus 3 to both sides. Those cancel, and I'm left with negative 1y. 30 minus 3 is 27. The last step has been the same on all of these so far. When it's beside it, I divide it. Those cancel out. Y equals 27 divided by negative 1 is negative 27. Okay. If I were testing this in my calculator, I would type in 3 minus negative 27 and see what that equaled. If it equaled 30, then I did it right. Number 12, draw my line down. Left side is simplified because they're unlike terms. Right side is simplified. My variable is on the left-hand side. I'm going to start by moving the one without the variable. So I'm going to move a 12. We get rid of a 12 by doing minus 12. Minus 12, that cancels. I bring down my negative 1/3. X equals 2 minus 12 is negative 10. We haven't seen one like this, but when I see a number underneath the fraction bar, that means division. So to undo division, I'm going to multiply. So I'm going to use parentheses to show my multiplication. The 3's will cancel, leaving me with negative 1x. 3 times negative 10 is negative 30. Still not quite done on here because I have a negative 1x, and my goal is to get x or y by itself or v by itself every single time. So I got to divide both sides by negative 1, and I get that x equals negative 30 divided by negative 1 is positive 30. Okay. To test to see if it was right, I would just do 12 minus 1/3 times a positive 30 in my calculator and check to see is that 2 or not. Okay. These next questions are real important for the checkpoint. This is how it's asked a lot of times. They'll give you an equation, and then they'll give you one of the variables in here. See, this equation has 2 variables. The ones we've been doing only have 1, but they'll give you a number to substitute in for one of the variables, and then we're supposed to be solving for x. So this y equals 3. This 3 has to be plugged in right there. So it'll look like this, 2x minus 3. Anytime we plug stuff in, we use parentheses. Plus 13 equals 0. Draw my line down. Okay, so this is the first time that I have simplification that has to happen on the left-hand side. Right here, I have some multiplication that has to be done. So 2x, negative 3 times 3 is negative 9, plus 13 equals 0. So again, I check the left and check the right. This still has simplification that has to be done. So 2x, negative 9 plus 13 is positive 4 equals 0. And then now I'm down to something that looks more like what we were doing on the previous page. I move the number that does not have a variable, so plus 4 gets a minus 4. Whatever I do to that side, I do to this side. Those cancel out. And I get 2x equals negative 4. I'm going to rewrite it up here. 2x equals negative 4. When it's beside it, I divide it, so I'm going to divide both sides by 2. And I get that x equals negative 4 divided by 2 is negative 2. And that's my x value when y is 3. Number 14 is a geometry application of this. Area is the inside of a figure. So I'm going to draw my rectangle. Area of a rectangle is found either by doing length times width or base times height. I know that my area is 28. The dimensions of the rectangle are 2x plus 2 and 4. Okay. Well, in either one of these formulas, all it is multiplication of these two things. So when I set this up, I do 4 times 2x plus 2 equals 28, because this is just base times height, or height length times width. Okay, I draw my line down. I look at the left side and the right side for simplification. This side has to be simplified. Parentheses let me know that it's double rainbow, so I double rainbow here and here. 4 times 2x is 8x. 4 times 2 is 8. So I have 8x plus 8 equals 28. Left and right are both simplified, so now I'm ready to start to solve. I always move the letter the number that does not have a letter, so that gets a minus 8 to both sides. Cancels out. 8x equals 28 minus 28 minus 8 is 20. Divide both sides by 8. X equals 20 divided by 8. That doesn't look like it goes easily in my head, so I'm going to type it in my calculator. That is 2.5. So x is 2.5 for this one. So we know this side's 4. We could plug it back in over here to figure out the other side. And this is what you'll have to do when you get into geometry next year. 2 times 2.5 is 5, plus 2 is 7. 7 times 4 equals 28. Here's another real-world example of equation solving. It says Stephen is a pizza delivery driver. He earns a flat fee of $8 per hour, plus an additional 75 cents for each D. Remember, for each meant multiply. So did per. Write an equation to represent Stephen's earnings of $101.50. So D represents number of deliveries. H represents hours worked. My equation is $8 for his hours plus 75 cents for his deliveries equals he made a total of $101.50. So this is my equation. Part A says if Stephen did 50 deliveries last week, how many hours did he make? So now we know that D is 50, and so we're going to use parentheses and plug it in, and it'll look a lot like the problem we just did, except it has real world applications here. So it'll be 8 hours plus 75 cents times his 50 deliveries equals 101.50. I draw my line down. I look at the left side and the right side for simplification. This has to be simplified. So 8 hours, take my calculator, 0.75 times 50 is 37.50 equals 101.50. Now I'm going to go through the normal process of solving. Okay, my normal process of solving is to get rid of the number without the letter, so I minus 37.50 from each side. That cancels. I get 8 hours equals 101.50 minus 37.50 is 64. Last step, when it's beside it, I divide it. So H equals 64 divided by 8 is 8. So that means he worked 8 hours that day and made 50 deliveries to get to 101.50. I could test it by doing this. 8 times his 8 hours plus 75 cents times his 50 deliveries, and this should equal 101.50 if I type that in the calculator. See you guys on Monday.